everyone. Today I'm going to spend 15 minutes talking to you about auth. So let's say it's your first time adding authorization and authentication to an application. I really liked this tweet from Nick Craver. I think that it's representative of a lot of people's experience. Say, step 1, are you ready to work on the auth code? New dev says, hell yeah, bring it on. And then the lived experience ends up looking something a little bit more like this. So the problem that many people have with authentication and authorization is that they do something like go to Google and they search for authentication, and then they're kind of often told by the internet at large that step 2 is do the rest of the fucking auth stuff. But then the rest of the authentication and authorization concepts, the specifications, the technical details, they continue to remain a mystery to people. And there's actually a reason for this. So you don't need to know everything in between to have a safe, secure, effective auth solution. If you use an identity as a service platform like Okta or Auth0 or Ping, or even database auth offerings like Firebase Auth or Supabase Auth, then this can provide you with standards-based authentication and authorization without costing you and your organization hundreds of hours that you would spend engineering this yourself. But I'm guessing you didn't come to this talk to hear me just say that and then walk off the stage. You're here because you want to know a little bit more about how to draw the owl. Or at least you want a 15-minute crash course in auth that kind of fills in some of the gaps so that you understand some of the magic that happens here. So I'm going to start with an introduction to commonly used open standards. And we'll begin with terminology. So digital identity refers to a set of attributes that define an individual user within the context of the function delivered by a particular application. So for example, let's say you're an online shoe retailer. The digital identity of your users is probably going to be something like their credit card number, maybe their shipping address, and their purchase history. Then there's authentication. Now, authentication refers to the process of verifying that a user is who they say that they are. On the other hand, we also have authorization. And authorization is about granting or denying rights to access resources. So here's a metaphor. If you're going to travel by plane, when you get to the airport, you authenticate at security by presenting your ID or your passport. And in this way, you're proving that you are who you say that you are. Then when you go to board the actual airplane, you present your boarding pass as authorization, and this grants you access to get on the plane. So if we return to the world of applications, then the concept of authorization brings us to the OAuth specification. Now, fortunately, OAuth standards are very clearly defined, but also, unfortunately, they're very dense, and they can be pretty difficult to grok. So I want to demystify OAuth a little bit. And in order to do this, we kind of have to take a little bit of a walk down memory lane. In order to understand what problems are being solved, I want to talk about why OAuth was created in the first place. So before OAuth 1.0 was established in December of 2007, if we wanted our application to access third-party resources from another party, it looked something like this. Let's say you're a user, and you use a web app called HireMe. And you use this application to do something like search for and apply for jobs. And then it also has the capability to set you up with interview scheduling. Let's say you also use another app called MyCal to manage your personal calendar. And now you've set up an interview with HireMe, and HireMe wants to add a calendar event to your MyCal. So before OAuth, HireMe would ask you, the user, for your MyCal credentials, and you would provide your MyCal username and password to HireMe. I remember doing this. Some of you may remember this also. And then using your MyCal credentials, HireMe can call the MyCal API in order to do things like create calendar events on your behalf. And it does this using the access that you provided by sharing your MyCal login information with HireMe. But I hope that everyone here can see that this is bad, right? This approach relied on sharing a user's personal login information from one application with a completely different app. this just isn't a good idea. If HireMe doesn't do their due diligence to protect your credentials, they really have less skin in the game than MyCal. So if they leak your MyCal credentials, that's not really catastrophic to HireMe, but it's catastrophic to MyCal. HireMe also can do anything with the MyCal API that you can do as a MyCal user. So it could delete your events, it could change your settings, it could access your phone number, or maybe even your payment information. So this is where OAuth comes in. This is the problem that OAuth was designed to solve. And I'm going to talk specifically about OAuth 2.0. And OAuth 2 is an open standard for performing what we call delegated authorization. Now, using OAuth, MyCal can delegate some authorization to HireMe to provide HireMe with limited access to its API without incurring any of the risks we saw from sharing credentials. And it does this using something called an authorization server. Now, an authorization server is really just kind of a fancy word for a set of endpoints to interact with the user and to issue tokens. So the purpose of OAuth 2 is to use an authorization server in order to perform delegated authorization. Delegated authorization allows a party that holds some authorization to delegate a subset of that authorization to another party. But it does this without incurring the risks of requiring either party to disclose their user credentials to the other party. So if we come back to the example with HireMe and MyCal, only now we're using OAuth 2, it's going to look something like this instead. Let's say MyCal has an authorization server. And for the sake of example, let's say the user is logged in with HireMe already. And HireMe now has set up an interview and wants to set a calendar event on your MyCal. So what's going to happen now is the browser for HireMe is going to perform a GET request to send an authorization request to the MyCal authorization server. MyCal authorization server is going to prompt the user to log in with MyCal if they're not already logged in. The user is going to authenticate with MyCal. And then MyCal's authorization server is going to prompt the user in the browser for your consent to allow HireMe to access the MyCal APIs to specifically add an event to your calendar on your behalf, but not do more than that. If you agree, then the MyCal authorization server sends an authorization code to HireMe in the browser. HireMe takes that code, and then it sends the code and its app credentials back server-side to the authorization server. And if everything checks out with that, then MyCal can issue an access token, which HireMe can use to call the MyCal API, but it can only do this within the scope of permissions that were accepted by you as the user. So HireMe can now set calendar events for the user with the MyCal API, but not do more than that. So this is great, right? Because nothing insidious is happening now. MyCal is asking the user to log in with MyCal. HireMe is not asking for your MyCal credentials. And HireMe can only create events, not read all your events or change your settings. So we have the issues with sharing credentials and with too much access. These things are no longer a problem. But once we were able to do this, the thing that happened then was that we wanted to do more than just call APIs. We wanted to log users in with accounts that lived in other systems. For example, maybe HireMe wants a MyCal user to be able to log into HireMe using their MyCal account, even if they don't have a HireMe account. Now, OAuth 2.0 is for delegated access. It's for authorization, sorry. It's not for authentication. So if HireMe does something like use the access token for the MyCal API and assume that by having this access token and successfully calling MyCal API with it, it means that the user can be considered authenticated with HireMe, then we start to run into problems. Access tokens are for the API. They're opaque to the client. So somebody could have stolen this token. The token could be from a completely different user. It could have been obtained for another client that's not HireMe and then injected into HireMe. And HireMe can't know this. So this is called the confused deputy problem. HireMe doesn't know where this token came from or who it was issued for. And authentication, if you recall, is about verifying that the user is who they say they are. However, this didn't stop companies from using access tokens for authentication anyway. So it became clear to the security community that we needed to address this. And in order to do that, we needed to formalize authentication on top of OAuth. We did this with an open standard called OpenID Connect, or OIDC. So remember, OAuth 2 is for performing delegated authorization. OpenID Connect is for authentication. And it's easy to get these concepts and these specifications confused with each other, especially because their flows and their details are built on the same foundation. So OpenID Connect is an identity layer on top of OAuth 2 for authenticating users with an authorization server. In both specifications, the authorization server's role is to issue tokens. And I talked about access tokens already, but for authentication, the authorization server is going to issue ID tokens. Now, the authorization server can issue ID tokens similarly to access tokens, which, as we saw in the example with Hire Me and MyCal, grant access to resources. However, unlike access tokens, ID tokens are intended for the client. So they're a fixed format that clients are able to parse and validate in order to extract identity information from the token and therefore authenticate the user and verify that the user is who they say that they are. Now, OIDC specifies the format for ID tokens as a JSON Web Token format, or JWT, which is sometimes pronounced JOT. And JSON Web Tokens are data artifacts that can be decrypted and validated as a means of ensuring that they weren't modified in transit. So now that we've got kind of the background and the basic concepts, let's put it all together. So when a user logs into an application that uses an authorization server, their credentials are sent to the authorization server. The authorization server is going to verify the user credentials, and it'll issue an ID token. If the application also needs access to APIs, the authorization server can also issue an access token as well. These tokens are then sent to the application, where the ID token is parsed and validated by the client in order to extract identity information and therefore log the user in. The access token can then be sent to an API to request access to data which can be consumed by the application. Now, identity is an immensely deep topic, but I hope that I was able to pack some helpful information into these 15 minutes. And I have some blog posts and some other talk recordings that are much longer that go into this in a lot more depth. So you can check these out at my website. So my name is Kim Maida. I'm the VP of Developer Relations at Cloudinary. I'm also an Auth 0 ambassador and a Google developer expert in security, privacy, payments, and identity. As a hobby, I make keycaps, miniatures, and also design custom stickers, which I take to conferences to give away for free to people. So please come talk to me if you have questions about Auth, or if you just want some free stickers. I'm at the Cloudinary booth, which is right out there. If you don't want to talk to me in person and want to connect in some other way, you can scan this code or add me on Twitter at Kim Maida. And I really appreciate you giving me your time today. So thank you very much.